Okay, question 3, the firm's total cost function is that. Total revenue function is that, where Q is the number of units produced and sold. Okay, how many units should be produced to maximize profit? All right, when you look at maximize, there's a giveaway, there's a clue. Right, and this you'll pick up when you do more and more questions, because when you see these words, you should be thinking about something. When you see max, you immediately think about a derivative.
Yep.
Okay, min and maxes are found using a derivative when you have different functions. Right, in this question, they're asking you to maximize profit, so you need the profit function. Total revenue minus total costs. Okay, the function is going to be, total revenue is what? 50Q minus 4Q squared. Okay, minus open brackets, total cost is 4 plus 8Q minus Q squared. Okay, happy with what I did so far? Still following? Still okay?
Yes.
Okay,
Yep,
good.
yes.
All right, stop me if you don't know what I'm doing and you want me to elaborate. That's fine, I can do that. This I'm going to multiply in. So it's going to change the sign. It's going to be minus 4, and it's going to be minus 8, and it's going to be plus Q squared. Okay, I'm taking the negative because it's negative total cost. So minus that, so it'll be minus 4 minus 8 plus Q squared. Okay, no more brackets. All right, next step, simplify. Okay, so I've got a plus 1 there, and I've got a minus 4 there, so I'm going to have a minus 3. Okay, I've got a 50Q and a minus 8. Okay, I'm going to have a 42Q. Okay, and I've got the 4 left over. There we go, that's it. All right, there's my profit function. My profit function is 42Q minus 3Q squared minus 4. Now I need to find the derivative. Okay, derivative of the profit function equals. Okay, apply your derivative rules. So I'm going to have 42 minus 6Q. Do you agree with that? Deriving the formula, deriving the derivative from the function.
Yeah.
Okay, I'm getting rid of those squares, right? I'm applying those power things.
Yes,
okay, so there's the derivative.
Yeah.
Right, the maximum will occur where the derivative equals 0. That's theory that would have come out of the textbook. Okay, that's the turning point basically if you're thinking about graphs. Okay, parabola graphs, that type of thing. This is a parabola actually, so the derivative would have the derivative would be the turning point of that graph, and it would be a maximum in this case because it's a negative 3Q squared, so it's an unhappy graph. Maybe let me just show that to you here, just so you know what I'm talking about. Okay, it's an unhappy parabola. Okay, because remember the parabola is sloping downwards, so it's looking like this. Right, this would be the maximum. Okay, that's where the turning point is. That's why you're going derivative equals 0.
Okay.
Right, where the derivative equals 0 gives you that turning point. And that'll either be a min or a max. In this question, it's a max because you've got negative Q squared. Right, so it's an unhappy graph, not a happy graph. Okay, if it was this way, it would have been Q squared. Then it's a happy graph, and then you would have had a minimum.
Okay.
All right, so that's just derivatives equal 0. All right, so whatever I have, I just need to work out the derivative. Okay, so when there's a min or a max, like there is in this question, I have to do the working. Okay, so derivative equals 0. (6Q) equals 42. Q equals 7. All right, how many units should be produced? Here they're asking about the number of units. Do you see that? How many units?
Yeah, yes.
They said Q is the number of units produced and sold in thousands. So Q equals 7 times 1,000 is 7,000 units. Okay, so here I'm going to go with 7,000 as an answer, which is option 3.
Okay.
Okay, only because they said in the question how many units. Do you see that?
Yes. Yeah.
All right, so because they're asking me for the number of units, it would be 7,000 units. Q has a value of 7, but in units, it's multiplied by 1,000. Okay, happy with that one?
Okay. Ja.
Okay, perfect.